Yo, yo.
That's my boy right there.
There we go.
Ha 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 ha.
Getting an echo now.
Could be. Just on Luke's side, maybe. Yeah. Because he needs to have the speakers come through something else.
Well, I don't have speakers on. The only thing I got on is Melon here and reverberating back through it. Let me check my audio setting.
I got to think about it in a minute.
Well, it seems good now.
Yeah? Okay, good.
Is it better?
It was working before. I don't know what happened when I did all these changes. I hear an echo at mine end.
Yeah.
How about now? Is it better now?
I think echo cancellation.
Yeah, I've got that on, bud.
Yeah. Okay.
Yeah, because I'm getting the echo too, so I don't know what the crap's going on.
Okay, well, I know it's me then, so I guess I'll have to try the other machine.
Let me look at my signs here. Nope. Getting that on you. All Pilar, yeah, I had them. Lay down the walls. Start recording. All righty then. Good evening, everybody. Okay. I don't know what happened. I guess he popped out. Okay, we're good on Twitch. We're good on the other channels, I suppose.
Oh.
Yeah, you know. Yeah. I had my sermon this week about hope. So I wish I would have recorded it, but then again, it shouldn't be, because I'm just a wackadoodle. Well, it is one of those. It's Saturday, everybody. Did y'all have a steak yesterday? I didn't. I had one tonight. So I got my steak in. So last night I was just exhausted.
I had fish and potatoes.
You had fish and chips today?
No, yesterday.
Oh, yeah.
I had baked beans and macaroni salad tonight.
Uh-oh. You're going to be warm tonight, buddy. Don't worry about the cold. You're going to get warm tonight. There's my boy right there. That's my boy right there.
Oh, low 40s.
Better now?
Yeah. Yeah, really better.
Okay, I'm doing it on my phone.
Oh. Yeah, calling in on the phone's probably the better, because if you're listening through the other, microphone on that device is picking the speakers up. And I don't know how to get around that. Unless we, send you a headset, which I can do. But because I have to have a headset, because the microphone, it will feed back and go, woo! Do all that kind of stuff.
Right.
Okay, y'all are on you're all on music now. And so I got it over there. Yeah. So I'm good too. I see chat's on, chat's off. So that's on that. Okay, I think we're pretty good here. Let me go to Rabbit. Alrighty then. Capture one, properties will be talk stream. Oh no, not that one. What the heck? Live stream studio. Is it that one? It is. Okay. So if I went like that. Oh, no. See, that's not what I'm trying to do. Well, shoot, howdy. All right. Anyhow. Video capture device. How's that? Oh, well, I'm here, everybody. There you go.
Crash again.
Yeah. And I am recording. I see it on Twitch. We are live on YouTube and Rumble. Crazy stuff's been going on this week, huh, Canuck and Luke? Been seeing some really strong quakes just off the coast of Oregon. And I made some comments about it on my morning report, which is on twitch.tv/Joe Slick Live. And what a cheesy way to plug that, right? But at 8 o'clock, well, it starts at 7 or 8. Depends on where you want. Arizona time, though, baby. And it feels like a steak Friday to me, but it's not. I had steak tonight, so I couldn't do it last night. I was feeling ill. Just run down. There's so much stuff going on in my house right now. Crazy stuff. I got to do some painting, it seems now. Anyway. Yeah. We clean the walls. Yeah, but where was I? Yeah, I don't remember. Yeah.
Earth, hopefully.
Yeah, planet Earth, I know, right? No. So, yeah, this week's been really crazy. Last Wednesday, we had a rabbit hole, and it was the bomb. And I thought we were going to replace or redo it tonight. Depends on how far we get through the subject on what's going on. This one, Canuck is really going to talk quite a bit about it. And, we're going to, I don't know why you got the I see an I there, Luke. Looks like a PB hole.
It or could be. Hole. I don't know what to tell you.
I don't want to see I don't want to see it. You don't have your emote on your profile there?
No, because it wouldn't let me play it from Twitch on my phone, so I had to copy the link and then go to Chrome and open it up.
Whoa. Well, on your phone, yeah, because that's Twitch.
But at least I'm able to be on it.
Yeah, and it sounds really good, too. Been missing my brother. He's been working a lot. Near beer.
Salute.
Salute, my brother. What else? I wanted to get over on Twitch where it can see us, but window capture, it's supposed to be you. See, window capture on this one, that one's supposed to be only you. So, and then Luke was supposed to be in another one. See how there's a little window? See, if I like it like this because
I can see Canuck a little bit.
Yeah.
There he is.
Yeah.
Blue hat and red shirt. So.
Yeah, that's how I wanted it. but we're gonna. Then I have to kind of go. Display capture. Let me see properties. Yeah, that one. Then I got to go to this one, and there's that. All right, so Twitch is going to be able to see it, but I don't. Um, I have to do share screen. This one for the you and I, but when I do that, it knocks us off. So if I went like this, yeah, it knocks you out. So then I would see it's a lot of work to do. It's not the perfect setup plan, but hang in there, everybody. We're trying to work it all out.
Yeah.
Luke doesn't have his emote up, or I put his emote up there. Tonight we're going to talk about Blanco Fracture Zone, which is just off the coast of California, and I mean Oregon actually. And it is a strike slip offset. I think what is the word? It's a, jeez. What is the word? Truncated dextral fault. Basically, it's a fault that goes to the side of the thing. I think that's the right word, but I'm not sure.
So it's like a transform fault, basically.
Yeah, strike slip,
Yeah.
and yeah, and then looking at this is the map that we're going to be watching, and let me see here. Put that over there. Where the hell is it? Oh, it's on this one. Oh, cool. This one here. So if I wanted to do this and we wanted to talk about it and draw some conclusions, put it on here. What was it? Blanco. All right. Then I wanted to open that one up. There's a reason I'm doing what I'm doing here. Just if we crash, we crash. I don't think we will. Crap. Open up with paint. Paint. Yeah. Okay. Yeah. There we go. Let me see. All right, back to you, Canuck. You can see the screen, and you can talk on what you want to talk about regarding this.
What we're going to do, we're going to learn about it first, Blanco Fracture.
Okay, cool.
Start looking at all the current quakes and go backwards, because I have.
All right, don't read the titles, just like you're teaching us.
Yeah, so
right.
We're going to do the wiki first, because it basically gives all the background on it.
All right, so I'm reading from the wiki and then move on.
Yeah, so that's what we're going to do. The Blanco Fracture Zone, or Blanco Transform Fault Zone, BTFZ, they call it two different things, is a right lateral transform fault zone, which runs northwest off the coast of Oregon in the Pacific Northwest of the United States, extending from the Gorda Ridge in the south to the Juan de Fuca Ridge in the north. The Blanco Transform Fault Zone is an approximately 350 kilometer long zone that varies in width between 20 and 75 kilometers. The Blanco Fracture Zone starts about 150 kilometers off Cape Blanco, so that's what it's named after, and extends northwest to about 500 kilometers off of Newport. It consists of a series of deep basins interrupted by transform faults. The western part of the fracture zone, from the Cascadia Depression to the Juan de Fuca Ridge, moves at 1.4 centimeters. So that's like 2 inches is 5 centimeters, so this would be what, quarter of an inch. The eastern segment from the Cascadia Depression to the Gorda Ridge moves at 3.9 centimeters a year.
Okay, what does the Blanco run?
It runs from
The
the
Gorda
Cascadia.
Ridge to the Wandafuca Ridge. And
Yeah.
how fast does it go?
It's less at the western part, so as you go towards
Okay.
Wandafuca Ridge, and the eastern segment from the Cascadia Depression to the Gorda Ridge moves more, like 4
Okay, so one side moves faster than the other. So the Pacific side moves slower. What's the Pacific side run? That'd be the most easterly one.
Where it moves the most is right where the quakes are happening now, to simplify.
Yeah, okay. I got you. I wanted to write it down is all.
Yeah, so the whole zone averages slip rate of 2, but it slips more.
I didn't hear you.
The whole zone averages a slip rate of 2 centimeters a year.
Oh, 2 centimeters, eh?
So would you consider that to be the plate it's pushing or getting pulled?
Well, they say because it's a transformed boundary, it's moving on one side. And if it's right, it would be just like the San Andreas, right lateral. So it's actually moving.
Yeah, see, that's the whole. See, this thing is, if I understand it right, the Blanco fracture zone, although it's separating, or one's going northwest and one's going southeast at 2 centimeters on average, the whole thing moves. However, but that whole section, including the edge of the Wandafuca, is actually moving northwest. Am I correct?
Yeah, because see the Gorda.
So you got to think of it in 2 more dimensionals. Yeah.
Yeah, the Gorda spreading ridge below it there with the arrows on it. See, that's what it's doing.
Yeah.
Because where the quakes are right now is right above that point where the Gorda ridge is
right
spreading.
Up in here, yeah.
And we've had quakes all around that, right? So that's what So when they talk about this, which we're going to get into it, but they say that what this part is doing doesn't really relate to Cascadia slipping.
Correct.
That's what they say because of where it is in comparison to how the ridges are moving. But anyway, we'll explain that more later.
Would the Blanco fracture zone, in your mind, be growing or shrinking, or just kind of, as it's moving, it's kind of staying the same length?
Well, it would be moving towards the other ridge, but of course the whole thing is all moving, subducting too, right? So eventually it's not going to matter what it's doing because it's all going to be subducted. To simplify. But it's because all the other stuff is moving down at the bottom, right? It's all adjusting. Like you have to think about it adjusting, right? That's what it's doing.
Right.
So it's like the whole JDF plate is adjusting to all the stuff that's happening at the bottom of it, where the little tiny Gorda plate is. So,
yeah.
And that's all the stuff that's been moving since the 7 in December of last year, 2024.
Right.
I'm trying to find Crook Point, Sand Creek. I'm trying to find the actual position on the North American plate where Blanco Blanco Cape Blanco is.
Yeah.
I got Cape Sebastian, but I haven't found the other part.
Unless it's got another.
Yeah, that's what I'm concerned with. I should just look at here because I want people to be able to kind of like look out there and go, okay, I'm at here. I know the Blanco fracture zone is named after me. You know what I'm saying?
Yeah.
Yeah, Needle Rock. That's an interesting rock. That's at Cape Blanco. Okay. And okay, it's just north of it. It's right up in here.
Like
Okay,
it's going to,
Coors Bay is up in the front of it.
yeah, it's going to explain the segments here next when we get to it. But it's
Okay,
primarily
cool.
the eastern
Okay,
segment
go ahead and read.
all the quakes happen. So it's breaking them down now, east, center, and west. So the eastern segment, the principal feature of the eastern portion of the zone is the Blanco Ridge, a 150-kilometer right lateral moving fault that is responsible for the largest earthquakes in the region. The ridge itself varies between 3.5 and 7 kilometers wide and peaks between 600 and 1,000 meters above the seafloor. The ridge likely formed through extensive shearing and subsequent serpentinization from the intrusion of seawater. The Gorda Depression, a 10-kilometer wide extensional basin, connects the eastern end of the Blanco Ridge to the Gorda Ridge. The basin is around 4,400 meters deep in the center, 11 kilometers across in the northeast to southwest direction, and 18 kilometers wide in the northwest to southeast direction. So they're getting like pretty specific.
Yeah, they are.
Yeah. So now the center section, the Cascadia Depression, connects the two halves of the Blanco transform fault zone. The depression is elongated around 20 kilometers in the northeast southwest direction, but only about 8 kilometers in the northwest to southeast direction. Roughly 500 meters of sediments line the floor of the depression, mostly turbidites. So here we're getting into the turbidites.
Okay, so are they talking about that little gap that's in the middle?
Yeah, it's talking about the middle part there right now, the center part. Yeah.
Okay.
It's saying channels cut through the southern end of the depression area are remnants of turbidity flows originating from the Missoula floods. So there's Missoula sediments out there.
All
the
right.
way there, so that's pretty crazy. But there are also signs of more recent local turbidity currents. There is also evidence of active seafloor spreading in this zone, indicating that the Cascadia Depression likely became separated from one of the spreading ridges that borders the Blanco fracture or Blanco transform fault zone. So they're saying there was spreading ridges there before, I guess.
Right.
Pretty crazy. The western part of the zone is made up of a series of depressions separated by transform fault ridges. The Surveyor Depression is the shallowest and smallest of these depressions, reaching a maximum depth of 3,300 meters and only measuring at 5 kilometers across. It is connected through the Parks Plateau fault to the Cascadia Depression. A small sill connects the Surveyor Depression to the East Blanco Depression, a broad basin which is composed of a series of small deeps ranging from 3,600 meters to 3,700 meters. Small intermediate ridges rise up a few hundred meters to separate these local ravines. A larger sill rises up to 2,900 meters depth to separate the East Blanco Depression from the final major depression, the West Blanco Depression. The West Blanco Depression is shallow in the south, reaching only a depth of 3,400 meters, but quickly reaches depth near the Juan de Fuca Ridge, dropping down to 4,800 meters. So as it goes out, it gets closer to the Juan de Fuca Ridge. It's like getting deeper. This basin is at a slightly different angle than the other western depressions, likely due to interference from the Juan de Fuca Ridge. All of these depressions are likely pull-apart basins, the result of extensional stresses from the two nearby spreading centers. So basically what it's saying is the spreading centers are having all these ridges and basins coming off them from them causing movement. That's basically what they're trying to say.
I have a map up now that shows Cape Blanco and how this thing's kind of put together. It's kind of very interesting because you see the strike slips. There's many of them, and yet there's these gaps between them. And it appears that the southern portion is more of that Gorda plate rather than the northern portion, because it's got a lot of these little splays off of it. However, they're both oriented the same way because of the spreading ridges. But this strike slip thing, it's like, they used to be together at one time. Did you read that?
Yeah, that's what they're kind of saying, because they're saying it was based on where the spreading ridges were before. So because it's kind of like it's the bridge.
What's the eye thing? The eye thing that Professor Nick talked about, where that's how they determine like the fence post. It's moved from the other fence posts. This is like two eyes on each point.
Yeah, the offset of like the fault.
Go ahead, Luke.
Could the 9.0 is 1700? Could that have cracked that plate through and then it started separating after that? Or is that's
a long way to go?
Too short, like a time frame.
Yeah, they would say this was like over a long period of time. Like they don't say that in there, but that's what I assume it would be, because they're talking about how there's multiple like ridges and basins in there. So this has been on for like a long time.
So it could have been.
Okay, so you're saying this Blanco fracture that we're looking at, it's been happening a long time, because the Gorda Ridge and then the Juan de Fuca Ridge. I'm gonna tell you how far apart they are actually in just a minute, because I brought it up here. I was wondering how long it took as well, Luke. Let's say at the end of one to the end of the other. It's basically 250 miles. So 250 miles would be about 2 million. Takes about 12 million years for that whole thing to rip.
In relative terms, that's almost kind of a blink of an eye.
Yeah, because it was like 400 miles in 40 million years. And, the Baja thing came off of Mexico, and it's exactly that size. And that's where the Macamba volcano that split in half and moved up? Or do I have them wrong, Canuck? It's that one that's down by Ridgecrest, not really by Ridgecrest, but on that side of the Gorda. It moved all the way up into Central Cal, where the thing split in half.
Now,
yeah, Pinnacles.
Yeah, Pinnacles is the half of it.
Yeah.
Okay.
I can't remember the name of it, the volcano.
I forget the name of the volcano. Yeah.
It begins with N.
Oh, yeah. Yeah.
It's named after the Neenac.
Neenac, yeah.
Yes, it is, because it's named after the formation that's right there, right by Garlock intersection. It's the Neenac.
Right.
That's half of it, half of the volcano. The other half of it is Pinnacles.
Yeah, Pinnacles. Pinnacles is the same as.
Yeah, the Pinnacles rocks and the Neenac formation are the same rocks. San Andreas ripped it in two.
Right. I'm looking for Pinnacles right here. All right, Pinnacles is right here. So
or past Hartfield.
Yeah, so what I'm doing is I'm measuring the distance from Neenach, which is right about here, up to Pinnacles. Oh shit, I lost it. All right. Parkfield, it's north of Parkfield.
So it's beyond Parkfield.
Yeah. Pinnacles right here. About 200 miles, a little over 200 miles maybe.
Wow.
Okay, so that 200 miles, and we're talking about the length of the Blanco fracture bone zone being 200 miles as well. Am I right?
Yeah.
So that must have moved about, 10 to 12 million years. That's pretty interesting. I didn't realize there was a correlation between the two. At the same time the Blanco fracture zone started is when Neenach was split in half. Because the Mendocino was south 200 miles. And that would be in San Francisco. So when the 12 million years ago, the Gorda plate, or just underneath that Gorda plate, is a line that goes out to out to sea. Really, it goes out to sea. And it's there it is. So I have it on JSL. So I'm going to show you guys in a minute here. Hold on.
Yeah, well, like kind of moving away from it, while the other is going underneath. So if you look at it that way, it would make sense why there's more quakes on the eastern part,
Right.
of it, which is where we're at now, because that's where that Gorda Ridge is pushing the Pacific Plate away from it.
Right, and the triple junction's at the green dot. So I'm going to try and share with you so you can see what I'm doing here. Okay, right there. And then there you go.
And to me, this, now that I started looking into all the quakes on this,
there you go. You can see what I'm doing here.
It would make sense why California responds to it, and then why everything up to the north responds to it too, because it's the Pacific Plate actually moving away from it. That's really what it is. So when it's moving,
did I measure it at 200 miles about?
Yeah, or 250.
I was like 200 or 250.
I think it's 250 there, but it's not too much different.
If the northern part's 250 and the southern part, down California or whatever is 200, I mean, that would mean that the northern half of that is pushing harder or getting pulled harder to spread further in that 10 to 12 million years.
Yeah. Well, if you think about it, the Pacific Plate is trying to go northwest, and then or northeast. No. Northwest.
What's interesting, okay, from eyeball to eyeball,
and then
200.
Coming the opposite way.
200 miles. It's 200 miles. So I was right. It is 200 miles.
So it is the same.
That's the same rate then.
So it's pretty interesting, I think. And it's going to make more sense when we start looking into all the actual.
Sure. So that Blanco fraction is 200 miles. I'm not going to measure the Gorda plate down there because it'll be taking us off our point. So we're having major earthquakes right here, and on the Blanco fracture zone in the last 3 or 4 7 days. Terrain. I'll put the
Oh,
ocean on that one.
it's really the biggest.
So I'm gonna, yeah. So let me push down in here. It looks like we had a 5.1, a 5.9, a 3.0. Today we had a 3.1 over there, 3.0, and a 3.2. Now, this is what USGS is going to give us. You know, we get a lot more from other sites. So basically 6 quakes. On the southern section, on the southern section of the Juan de Fuca, where, let me see, do I have a map up? I don't have, I got rid of the map. Okay, I'll just show you on this so we can see, because this is the reason why we're, I'll share that window. This is the reason why we're talking about Blanco fracture zone tonight, because there's other channels, and I want to not have them afraid. So you can see the earthquakes that are happening. They're along this fracture zone. The orientation and, you know, the up, you know, where one doesn't look like it is because they're flat maps versus not flat maps.
Yeah.
You know, the Mendocino doesn't go straight. You know, the orientation is like what we have it. So, you know, it looks, you know, you have to rotate the Earth because the Earth is on an axis, right?
Right.
Oh, we got some little quakes. So, you know, we're going to come back to this map because I'm going to talk about some of there. But go ahead, continue with
Yeah. So what
with
we're
your
going to do at the end of that, where it talks about the earthquakes themselves in the wiki. Most large events in this zone occur on the Blanco Ridge, as the motion on this fault accounts for the majority of the plate movement. Strike slip faulting occurs in this region. Motion on the fault is parallel to the motion of the plate. Tectonic activity in the central part of the zone is weaker and deeper than on the Blanco Ridge. Typically, this activity is consistent with normal faulting, although interference with the Cascade Depression spreading center changes the motion on some of the faults. Shallow earthquakes consistent with strike slip faulting occur on the western side of the zone, but their large distribution indicates that multiple faults exist. Generally, these faults run along the walls of the bathymetric basins, but near the Juan de Fuca ridge, they become distorted and rotate towards the ridge axis instead. Now, the last part talks about a bunch of the swarms, but we're going to go into more detail on that with the other list that I have. On January 9th, 1994.
Okay, hold on here. I wrote it down here. Taking my notes. Sorry if I interrupt you. The western side it gets more strike slip action, whereas on the eastern side gets more normal faulting.
Yeah.
Okay, because they're making real clear definitions on what's happening on both sides of this strike slip Blanco fracture, right?
Yeah, as they're dividing it into the sections. So it does have quakes out on the other parts, but not like it's not as busy as what it is on the eastern side.
Okay.
Close to the Gorda Ridge. That's basically what they're saying. And it's spread out on a bunch of different faults, like the farther you go out. Whereas in the eastern section, it tends to stick to certain ones, and the big quakes are on the usual ones, not spread out when you go.
Okay.
It goes out farther. So now talking about the swarms, because this is what I noticed. I didn't.
Okay.
So this one
Well, lay a foundation, then tell us what your deal is.
and then we'll look at all.
Okay.
This one is given a few.
I'm not going to change the image for those people because they got to see what we're talking about.
So on January 9th, 1994, a large series or swarm of earthquakes occurred in the East Blanco Depression. Acoustic signals recorded during these events indicated that an eruption occurred in this zone. So there was also an eruption with it too. Further investigation
Wow.
revealed an active hydrothermal vent, the first of its kind to be discovered in a transformed fault zone. So that's pretty interesting. Well, I looked up that date and I said, well, we've talked about the Northridge quake. Well, guess what? The Northridge quake was January 16. So this happened a week before Northridge.
Oh my gosh.
So that's pretty interesting.
Yeah. So what it's telling me is that the Blanco fracture zone right there, I don't know what size of earthquake was it?
It gives it when we look at the list. I don't
Okay,
remember.
that's fine.
I think it was
But anyway, the earthquake you're talking about, it's so thin there and it's so broken that magma can rise up from inside that, and that's probably what created the earthquake itself, is the magma rising up. I wonder, is a hydrothermal event, that means, it was mainly water, but steam in that. But I wonder just how freaking dangerous it is right there in a Blanco fracture zone. Wow. That's an interesting thing there. Okay, continue. I got an abstract on it.
Yeah, so now the next swarm it talks about here, it says in March and April 2008, a swarm of moderate earthquakes occurred both near and within the Blanco zone. The swarm began on March 30th when over 600 measurable tremors began occurring north of the zone within the Juan de Fuca plate. On April 23rd, activity moved to the Blanco fault zone itself near its junction with the Gorda Ridge. Now, when I saw that, I said, well, 2008, I'm pretty sure that's when we studied, was one of the Chino Hills fault quakes. It's 2008. So that's pretty interesting. So we got Northridge, 94. We got Chino Hills quake, 2008. And then it starts talking about these other things. Another series of earthquakes occurred in June 2015. Now, I can't remember if anything happened in 2015. We'd have to go look it up. Spread out over a period of days, some reached magnitude 5.8. So it had another big swarm. And in December 2021, a swarm of earthquakes occurred on the northwest portion, so out farther, of the Blanco fracture zone, with multiple being stronger than magnitude 5. Well, that was the same year we had the Sandpoint big one, 8.2. So it swarmed after Sandpoint. So I thought that was interesting.
Mm-hmm.
And June 15th, 2022, well, that was 2022. That was before the big Colima quake and before we had those 6s up there in Northern California. There was 2 6s at the end of the year in December 2022. So it was another swarm of 9 earthquakes took place, the maximum magnitude being 5.6. Okay, so it talked about some of the swarms in here, so that got me interested. So I did my Google AI search, which is what we're going to talk about next, because it has them all detailed going. Like the most recent ones from right now, going back to 2000, and then talking about a few of them before that. So that's what we're going to look at next, is that Google search that I did for it.
All right. All I'm doing is trying to add the information you're talking about to our document so that when we discuss, though, I mean, we can look at something. You know what I'm saying?
Yeah.
So that's kind of what I'm trying to do.
Okay. So now I'm just going to read what my Google AI search
All
did.
right, bud.
I searched basically for Blanco fracture zone quake list, and it gave me like all the lists of the quakes there and the swarms and all that stuff. Multiple seismic swarms and individual earthquakes have been recorded in the Blanco fracture zone, located off the coast of Oregon. As a highly active transform fault system, the BFC experiences frequent but typically moderate sized earthquakes. So now they break down the activity here in detail the last 3 years. So 2025 to 2022, and they start with most recent and go backwards. September 27th, 2025, a magnitude 5.1 earthquake occurred in the BFC offshore of Oregon. So that's the one that just happened. September 25th, 2025, a magnitude 5.9 earthquake struck off the Oregon coast, followed by predicted aftershocks. This came just 2 weeks after a magnitude 5.8 quake on September 8th. So they say this has been going now for like 3 weeks, really. If you
Okay.
count one that happened on September 8th. September 9th, 2025, a cluster of earthquakes, including magnitudes 4.9, 4.4, and 5.1, occurred in the BFC. So they were aftershocks to the one on September 8th, I guess that's what they're saying. June 15th, 2022, so they're going back 3 years now. A swarm of 9 earthquakes occurred, with the largest having a magnitude of 5.6. And then they jump back to December 2021. A significant swarm of 88 earthquakes, including 15 with a magnitude of 5 or greater, occurred on the western portion of the BFC. So it was out on the other part. And I remember because we were looking it up then, because it was odd that they had swarms out there on that farthest point. It was usually in like where we're having the quakes right now. But it just happens that that was right after the Sandpoint quake that year. So that's pretty interesting. Now, the next section, they break it down between 1900 and 2021, and they're doing the same thing. They're going backwards. So they're going to list them. So
Okay, bud.
pretty good. The Blanco Ridge, the main fault in the eastern BFC, is responsible for the region's largest earthquakes. So that's where they're happening right now. Seismic records show many events with magnitude over 5.5 in the BFC in the 20th century. Noteworthy events and swarms include, so they're given the list. So they go back to 2019. A magnitude 6.3 earthquake struck the zone, one of the larger recent events. So that was same year as Ridgecrest. So that's pretty interesting. So there's a 6.3 out there. I don't know what the exact date was, but we'd probably be able to find it if we went and looked up that year, because it would have been big enough to show up on the major lists. Multiple earthquake swarms occurred in the BFC in 2015, including one in June, with quakes reaching magnitude 5.8. So it had a big swarm in 2015 too, which would have been the year after the Napa earthquake, because Napa was 2014. 2012, a magnitude 6 earthquake was recorded out there. So that's interesting because 2012 was the last Haida Gwaii big one, which was at the same time as Superstorm Sandy. So it was acting up that year too. And then it goes 2008, a swarm of moderate quakes occurred in March and April, which is talked about there in the wiki too. So I thought that was interesting, because that's the same year as there was the Chino Hills quake that same year. 2003, a magnitude 6.3 quake occurred. Well, I'm pretty sure 2003 was the same year as the San Simeon quake. And we looked it up before.
Okay.
Yeah.
So when you're saying that, this is the second time you said it. It's registering in your brain because we're saying, hey, wait a minute, this event took place the same time this other event took place.
Yeah.
And it's natural for us to, because you're like myself and I'm like you. And I think Luke would ask the same question. Are they related?
Yep.
What's happening out here? Is it related over there? Because how weird this quake's happening and that quake's happening, in a relatively short time period between the two.
Yeah.
So I think that's.
I'm trying to think about it as the Pacific plate is moving, right? At where this fracture zone is. That's what it's doing. So when it's doing this, the Pacific plate on all the other edges are adjusting in the same region, right? So that would be north of it and south of it, which is California to the south, and Vancouver Island or Washington are going up Haida Gwaii, right? Because it's still the Pacific plate and it's moving. So it's adjusting like in all these spots all along. And that's probably why you're getting these quakes in those same areas that are notable. Yeah. And now it goes back here farther. It talks about the year 2000. A magnitude 6 earthquake was recorded. Now I'd have to go back and see when it was and see what was happening in 2000. I can't remember. And now, but there probably was like a notable quake in California, probably 5 or bigger in the same region, which I can't think of right now. 1994 is pretty obvious because we mentioned that one already. So it had a big swarm and eruption out there right before Northridge quake, so a week before.
I find that the fact that it erupted, that's like what?
Yeah.
You know what I mean?
There's a lot of pressure build up there with it moving. It moved the week before. 1928, a magnitude 6.3 earthquake was documented in the BFC. But what's interesting, that would have been the year, because 1929, I think, was one of the big quakes that we talked about too. Was there 29? Wasn't that one of the Santa Barbara ones? I think so. That would have been right the same time period.
1829 or 1929.
1929 was the Santa Barbara quake. I think one of the ones we talked about. So this was happening in 1928. Now I don't know the exact date in 1928, but we'd have to look and see. So it would be like the same time period. And then 1917, it had a magnitude 6.5 out there, which I don't know what time of year it was, but that was the year before the big San Jacinto quake in 1918. So I just, when I started looking at all these numbers, it's like getting crazy.
Yeah, I mean, it's constantly looking at. And then
at the bottom of this, it says, due to the horizontal strike-slip motion of the Blanco fracture zone, earthquakes there do not typically produce the vertical seafloor displacement necessary to cause a major tsunami. While they are distinct from the nearby Cascadia subduction zone, some believe the BFC activity could add stress to the southern end of the subduction zone. However, seismologists generally agree that BFC activity does not trigger major Cascadia event. But they say, because they say it's mainly related to the Gorda spreading ridge, which is actually moving Gorda.
Yeah, okay, so Gorda spreading ridge begins at the Gorda or the Mendocino, goes all the way to the Gorda Depression. And then as we move up the Blanco fracture, we get into the Blanco Ridge, We go a little more, we go to the Cascade Depression, which is the halfway point between the two, and then it kind of steps northeast, and it's a severe depression, and then it goes to the little bit more northeastern Blanco Depression, and then the Blanco Depression at the top, then the Juan de Fuca Ridge. So the Blanco is about 12 to 50 miles wide and about 200 or so miles long. And they broke it down into 1, 2, 3, 4, 5, 6, 7 areas. And each one kind of moves at a different rate. Seems like the western side moves about 2 centimeters. The other side moves a little slower, if I read right. And these depends on which sector is going off. That, you know, the reason I bring it up, because in the Blanco Depression, if there's earthquakes happening there, then where are the other quakes happening? If they're happening in the Cascade Depression, where are the other earthquakes happening? You know what I'm saying? I want to see if they're, you know, which sector those earthquakes are happening, and the other earthquakes that are happening, like, you know, in downtown Los Angeles. So if Los Angeles is quaking and then the Blanco fracture zone is quaking, where at along the Blanco fracture zone is it quaking? Is it the Cascade or the Eastern? You know what I'm saying? So if we can see some similarity between those, you know, like Ridgecrest going off. Right before Ridgecrest, this was going off. Mendocino in this area. And then this area went on afterward.
Yeah.
So, is there like a big enough quake that you get a multitude of sections going off at the same time?
Good question.
Well, I think the majority of the bigger ones are always in this eastern part. Not always, because they've had some.
You mean on the Juan de Fuca plate itself?
Yeah, well, in the eastern part of this fracture zone. The majority of them. Because most likely they could feel them on land if they're big enough, but the ones that are out there in the west, the western part, I don't think you'd feel them because they're too far out there. Like in general, when I looked up the quakes on all these, they're between 200 and 500 kilometers off the coast of Oregon. But they have to be big enough that people can feel them on land.
On land, yeah.
Yeah,
and if they're very deep, they're not going to feel them.
Yeah.
Like I have a list of all the quakes here, which you're talking about. So I'm not trying to say what you're saying is off.
Next, because it has more stuff on it.
And that's fine. We can. I just want to do a quick visual.
Yeah, and I can use some notes that it's going off before all the big quakes in SoCal, and also before the ones in Washington.
But I guess the point that I was making, Canuck, is you were talking earlier, and you hear magnitude 6.3, magnitude 6.3, you know, quite a bit. And that sounds like one section of that plate, you know, slipping and causing an earthquake. But let's say we had, like, I don't know if it's happened or not, you know, but let's say we had a magnitude 7. Would it be like 3 sections slipping at once? You know?
Well, maybe, but I've read other stuff about that. They said that they think it can only go as high as like a high 6.
Okay.
The Blanco?
Yeah, they say right now, yeah, because it usually does it in like one segment at a time, not all 3.
Not a full rip.
Well, we've seen very strong quakes here. I'll let you know from 1700 what's the strongest they have on record on USGS only. Okay, 7.4 is the strongest, and it includes the Mendocino. So don't, you know. And I'll zoom in. It's crashing on me. I'll zoom in on this to get just these quakes. 27 quakes in and around it. Strongest is a 6.9, and that's way south. Oregon coast, that's the strongest quake, 6.5. right in the Blanco Depression. So you're right, Canuck. It doesn't really go huge,
That's good.
you know. I mean, south of it did, but down here, but in this section right in here, that's the area that I'm looking for. The strongest is a 6.5, and it's right there.
The
That
closer
happened in
you get,
1917.
to Mendocino, it can get bigger.
Oh yeah, Mendocino will go super big. Yeah.
So what we're going to do, we're going to go to the significant historical earthquakes in the Pacific Northwest, because I like how they've done this, because they are basically listing any fives.
Okay, you handle those, and I'm just going to have the picture up. Okay.
Yep.
Okay.
So I'm just going to, because on this list, they go all the way back to the Cascadia megaquake and tsunami in January 6, 1700. But then they start the next one after that they know for sure happened, based upon people reporting it. It's October 23rd, 1853. And they're listing all the ones also in the Mendocino area for this too.
All right.
So they start with 1853. So Eureka was shaking out there.
That's
So
south of us.
yeah. And then next one, they don't know what the magnitude was, but it was big enough for people to feel it. March 20th, 1855. And see, these years here, 1853, 1855, are all leading into the big Fort Tejon quake.
I was going to say, Tehachapi, yeah.
Yeah, in January 1857, right?
Right.
Which we talked about in a bunch of the other shows. So then it's showing that there was another quake that same year, June 14th, 1857, out by Eureka at intensity 6. And then it talks about November 13, 1860. Well, we know there was a big, that was the year of one of the San Francisco quakes that we talked about before. The one that was in the same place as where 1989 one was.
Oh yeah, that's what that was the one we rabbit hole that nobody got. 2 hours rabbit hole didn't work out. So hey, how you doing?
So see, then it's given more. It was shaken in 1864 at a 5. Oh, I guess that was Georgia Strait, so that was Vancouver.
Oh, it's way up. All right.
So that's way up there. But see, then it was talking about 1865, Eureka again. So that's all leading into our 1868 Hayward Fault quake, right? So
1863?
Yeah, it was acting up 1864, 1865, and then we had the big Hayward Fault quake in 1868. So it was acting up the previous years to that.
Yeah.
And then the next one they list the Antioch big quake. So that was the North Cascades on there.
Antioch, North Cascades. So is that in Northern Oregon or is it in Washington?
That's the one in Washington. But of course, it fouled all the way down, right? So
that's sure. Yeah,
even down to Northern California. And then the one we talked about.
Shoot, all the way to Southern Cal or Northern Cal?
Yeah.
Well, interesting, because when Mendocino goes off, it's all 90% plus is always on the northern side of the Mendocino, and people in Southern Cal can feel large earthquakes. They feel them in San Francisco, all the way up the coast. On the Blanco, it would have to be very large for Southern Cal to feel it, but maybe San Francisco.
Yeah, it'd probably have to be like Cascadia size.
Oh no, you'll feel Oh, you'll feel that in Mexico, dude. A 9. The whole United States would feel it. All of Canada, all the United States, Mexico would feel it. A 9. 9 is freaking stupidly incredibly strong. But so when you're
and then the next it talks about the 1873 quake, which is the one there at Southern Oregon. We talked about that one before.
Right.
That they now think was a 7, but on this
and they see that was on the Cascades, right?
Yeah.
That they believe that was a Cascade quake.
Yeah.
And that's yeah.
So for SC, the source here, they have subduction quake. That's what SC means.
Yeah, that's what. Yeah. God,
quake. I don't know.
Luke has been so busy with stuff. That quake that was in Oregon, I think it was. What was it near Florence? Oh, what the hell was it? The one the first one we talked about was in those mountain ranges.
Oh, yeah.
I gotta, you know. Well, anyway.
Yeah, and now I'm gonna.
I forget what they were called.
To the 1900s.
Go for it.
Be here forever. And so when I was looking up this, I saw, it went off in that same area, 1899. Well, that was right before the Yakutat quakes. So on this list, I started looking and saying, holy crap, all these numbers are like crazy.
Agreed.
Yeah. And then I looked down and I said 1906. Well, that same area was shaken the same year as San Fran quake.
Yeah.
1906.
Before or after?
I think that would have been like right after, because I think
that's what I thought. That's what I thought, because I think it's pressure moves north.
Yeah. So
I think it moves the same way the Pacific Plate moves northwest.
Yeah, and so there it was acting up multiple times in 1909, all that same area.
Yeah. Intensity 8, Rio Del. Yeah, you're right. Mendocino area, Rio Del.
Yeah, and I think wasn't that the year that the Lompoc quake was? 1910, I think. Or it was in that time range, I think.
Let me see. I'll do it real quick for you.
Yeah, Lompoc. I'm pretty sure it was that same time period. The big one off the coast there.
1927 was a 7.1.
Oh, so it was down farther then.
Yeah.
Well, I must be thinking of some other one. I'm pretty sure there was another one like 1910 around there, but I'd have to go look it up again.
Let me see. Fort Tejon was 57. Frisco was 906. 7.8, 1872. Owens Valley, 7.4. 1989, 94. Yeah, I don't have anything in Cali on this list that I just did. So 1906, and then it jumps all the way to this is an incomplete list.
Yeah. And so we jump into the next was acting up 1914, 1915, multiple quakes, 1917, and then 1918. Well, 1918 was the big San Jacinto quake.
Right.
Yeah, so it was acting up with like high 5s, low sixes out there.
At what date?
From 1914 to 1918. So it
All
was
right.
a bunch.
1918, San Jacinto went off.
Yeah, and I think that one was at the
Imperial
end.
Valley went in 1915. So you were close.
Yeah.
And both of those were 5.5 to 6.7.
Yeah.
In 1920, did we already talk about 1920?
Yeah, 1920 was another Vancouver, Georgia Strait one. That's the inside part of it.
That was the LA area. Inglewood had a 4.9.
Yeah.
1923, Humboldt County.
Yeah, and see 22, where it's showing those ones that were pretty big, 6 and 7.3 to 7.6. Well, that was the exact same time that Kamchatka was going off.
Interesting because January of the next year, January 22, Humboldt County had a 7.2.
Yeah.
And then Santa Barbara was in 1925.
Yeah. So see, it's all running in like 1923, 24,
Mm-hmm.
25.
And then 27 was Lompoc. Santa Barbara was 6.8. Lompoc's a 7.3. Then Eureka in 32.
Yeah.
So,
well, I guess the point I'd like to make is we're having these quakes, in there now, and coincidental, Kamchatka has had like how many big quakes here in the last couple months?
Massive amounts, yeah. At least 4 7s and 2 8 pluses.
Well, you have to remember that it's the opposite side of the Pacific Plate, right?
Right.
Hey, what's interesting is Greenland's had 2 large quakes, 2 5s in the last couple of days.
Yeah.
And Southern Iceland popped a little bit too.
And if you start going
Eastern
down
Greenland.
less more, look at 31, 32, it's going
Yeah, I know, right?
Right.
Eureka in 32 and Long Beach, that was in 33.
Yeah. So see, it's all making sense. 34, you had the big Nevada quakes.
Okay.
And you had Colima also go off with multiple 8s and 7s and 32.
That's a volcano in northern or central Mexico, right by Jalisco, right by Guadalajara.
And you keep going down.
Puerto Vallarta.
Going crazy still in 36, 37, 38, 39. It's like every year. It's like getting a big one. And see, now we're getting into the range of our 1946 quakes, which we've talked about before, because look at it going off 44, 44, 45, 45, 46. And
41 had Torrance. Gardena had a 5.4.
Yeah.
And Desert Hot Springs was in 48. So that was a 6.4.
Yeah.
So that's basically, where's that? Where they go gamble. I don't go there.
Vegas?
Palm Springs.
Yeah.
They go to Palm Springs, and Palm Springs is the one that's Desert Hot Springs. It's virtually the same area. That would be right next to the Coachella Valley. So it's right at the top of this part on the San Andreas. It moves through there, and that'd be the bottom of that compressional section, or the top. It's almost where it goes. The fault, the San Andreas fault, bends right there. It goes in right there, then shoots up through Big Bear, then out through the upper desert. And Landers is in that area. Big Bear's in that area. And also is Hector Mine, which all, 6.3 or 5, and then 2 7s. that have happened in that area. So interesting that Desert Hot Springs went 6.4, and that was in 48, and you had something in 46 as well.
Yeah. So it's acting up.
What happened after 48?
Well, 48, we go into 49, which 49 was the big Haida Gwaii quake and all that stuff. 46 was the big Vancouver Island quake, and Puget Sound went off both years, 46 and 49.
Okay. So what happened along Blanco in 48, 49? Anything?
Yeah, they have 2 in 48 Blanco fracture zones.
Really?
5.8. Yeah, and there's a 5.6 in 47. So it was acting up both in 47, 48. In 49, they have 1 going off in that same area. 5.9, same as what we just. So that's interesting. Then at say 51, they have Blanco going off 3 times, which is right before. No, actually 4 times. 4 times if you include the Petrolia quake.
Yeah.
All before
1952. Yeah.
And that's when
Tehachapi. Yeah.
was nuts too.
Yeah, Tehachapi went July of 52, 7.3, and then August 22 went to 5.8 in 1952.
And then they still have it going 54, 56.
54, yeah, Eureka went off 6.5.
Yeah.
And then San Francisco 57 had a 5.7.
And then 59 was Kamchatka big again and Lake Ebgen. And it acting up
Right.
as well. So.
Well, I saw a video last week where somebody put a water, a little portable water on the ground in Yellowstone, and the ground is shaking and it's bouncing up and down.
Yeah, so it's feeling vibrations.
There's something pretty strong vibrations if it's knocking a bottle of water up and down. So they're alerted to it, but they don't want to create the fear.
And see, it was acting up in 60 when the big chili quake was. It was acting up before when Alaska was. So it's crazy.
In 64?
Yeah.
What about 68?
68 was Borrego Springs quake.
Yeah, Borrego Mountain 6.5. Yep.
Yeah, and then it was acting up then too. In 68, there's a 6.1 out there. And
wow. See, whatever happens in Southern Cal, you can bet the Mendocino or the Blanco fracture zone is going to respond because that pressure moving. And I think through all of our discussions, that's the same theme through the context of earthquakes everywhere, right? The theme is that these earthquakes are happening and we see the plate movement, and we can say, okay, this area goes off and then we should be looking over here. Now looking for an earthquake for 2 years, you're not forecasting it,
No,
but
for the pattern. So
you see the pattern.
You should be able to be looking for certain spots to get hit based upon what it's.
Correct. And hence we were looking in this area here, and actually what happened, I was calling a 6, and I don't think there was a 6 there. But it happened right where I was saying. I didn't say the Blanco fracture zone, but I said up in that area, Blanco or Mendocino, because I can see the pressure moving on up. Also, your favorite word, the lineament. What lineament is Blanco fracture zone?
Well, I think it's Texas lineament.
Texas lineament, yes, sir. And the Texas lineament, often we talk about that at great length. Go ahead, Luke.
Well, I guess the question I have is the years that the Blanco is going, do you see like corresponding quakes like on the hot spots like Yellowstone or Hawaii at all?
Good question.
Yeah, you'd have to go and look at the Hawaii things for that year, and I bet they would match up because I've done it with a bunch of the California quakes already. So you'd have to take the dates of these quakes on the Blanco, for example, and then compare them to what was happening in Hawaii the same year. But based upon all the ones I've done with California, usually Hawaii's acting up. So it's like Kilauea, Mauna Loa.
Yeah, that was part of our show on Wednesday.
Yeah,
Gosh,
yeah,
that was a good one.
The show that only
you and I got to enjoy. I know.
because we were showing in that one how Hawaii, southern Peru, and northern Chile all go off in like big triangles.
Yeah.
Like hundreds of years.
But, I know when we're talking about the Blanco fracture zone, that a lot of it were corresponding quakes to the north and the south of it. But it's interesting if we could correspond the quakes. They may not happen as often either, but the east and west of it too.
Yeah, I've already done a bit of that already because I've been studying all the eastern ones. And usually you get a big quake on the east, Azores, Spain, Portugal, East Coast like Virginia, New Jersey, New York. You always get big ones, or, well, I shouldn't say big ones, notable ones there before the West Coast has a really big one. So it's the same thing with all these. I'd have to go and look every single year, but I know for the California ones, because I've looked into them the most.
Right.
They usually happen the
Right.
same year.
Yeah, the studies that we've done like over and over and over and over.
So it's
you start to hear it.
And Pacific plates moving, right?
Yeah.
That's what it is if you want to simplify it. So it moves on one side, it moves on the other.
Well, we stopped in 1968, 69. Santa Rosa, which is north of San Francisco, went off.
Yeah, and it was acting up out there right before 71 as well.
Yeah, 71 was San Fernando, and 73 was Point Mugu, which is both in Los Angeles area. And Santa Barbara went off in 78. Butte County, I don't know where the hell that is. I think it's up there in like Humboldt. That went off in 75. South Bay and San Francisco was 79. Imperial Valley way down here. I'm not here. I don't even live there no more. It's so weird, dude. Not living in Southern Cal. 79 was Imperial Valley. 6.4. So anything in 79 on your list?
I gotta go backwards here. Long crazy night.
78. I see 270. Brooks Peninsula, Vancouver went off twice in 78.
That's the.
And then, of course, the eruption in St. Helens in 1980.
Yeah.
So in 1980, Livermore East Bay went off. East Bay 5.4, 5.8. Both of these happened in January of 1980. And Mammoth Lakes in May, 6.2. Then Eureka, at same time on St. Helens, right? 7.3 Eureka. And then the following year, Imperial Valley, or down in Westmoreland where the volcano is down in Southern Cal, that's 5.9. And then Coalinga in 83, but how are we looking at in the 80s? 81, Washington, seismic Blanco fracture zone. In 81, 6.4. And then Mendocino had a 5.5 in 83. Then Eureka again, all the way to this one fell 6.6, fell all the way to San Francisco and up into Oregon. 6.6 on N84.
Would be basically leading into 89, really, once you get within 5 years of it.
Yeah. Well, we're working at Blanco fracture zone again in 85, 6.3, 87, Mendocino 5.5, Blanco again 88.
85 was the big Mexico City quake.
Yeah, it's September 19, right?
Yeah.
That was what, a 7.8?
It wasn't in Mexico City. It was toward the coast, but Mexico City is so weak, it felt it big time.
Okay.
Yeah, because Mexico City's in the big basin.
Actually, I think it happened in Guerrero or I don't know, one of those other states toward the coast. That was what, 86, 85?
Yeah, 85.
85, we have a Blanco fracture zone in March, 6.3.
Yeah, so that would have been before.
All right, and then
but it's like pattern. If that's acting up, it's not good for anything.
Right.
Right.
Well, you know when Ridgecrest happened, we watched it up there in Vancouver, saw 2 5s up there, and we go, And then Blanco happened, and then we said, okay, Southern Cal's going to get nailed. And it wasn't 12 hours and Southern Cal got nailed. And then it got nailed right after. We were both thinking, or many of us were thinking, you know what? It's not done yet. We just had that impression. And yeah, that's when Ridgecrest had the 7.1. That's, basically disrupted, 80 miles of dirt.
Yeah. Well, when you think about it, it's still the edges of the Pacific Plate adjusting. Right?
Yeah. That's kind of what I'm after.
When you simplify the edge of one part of the Pacific Plate in the region, the other edges are going to adjust.
And again, that's the beauty of what we're learning, even with Nick Zentner, who's on YouTube. Everybody, if you want to go see the guy, he's got 5-6 years worth of videos that we've all been part of and we all partake in. And in the videos that we've and Canuck and myself have done with Luke, that's all on Rumble, also on YouTube. Look for the rabbit hole on both of those. And we show the faults and how they rupture up and down the coast from Mexico all the way up to, Vancouver, and the fault systems and how they work, and then how they are related to other faults and other quakes happening along the plate boundaries. And with this new series, Alaska, we're going to learn a lot about what's happened up there, because a lot of times when Mexico's going off, Alaska's going off prior to anything in the middle. It's just weird that way. I've seen it often, and Guerrero go off, Salvador go off, and then all the way up in Alaska goes off, and then the southern part goes off in the middle. So it's a trip.
And we're going to be this list more, because we're going to talk about all the bigger quakes in Oregon and Washington and all that. And as we go up, we're going to be
right
over again. We'll just be going into more detail on what fault it was on and all that.
Well, I like the fact too, Bud, is we have to redo that other one, because we talk so much about the cascade and those faults and those earthquakes happening. People don't know that there are earthquakes happening that is in the Cascade Range, And there are other earthquakes that are real close to it that are not related to the Cascades at all.
Yeah.
And that, like I said, it was 2.5 hours or 2.25 hours, and it's like, God bless it. Let me make sure this is voting or recording. Yeah, we're still on.
Started with Hayward Fault and morphed into
Yeah, it was really, really, really good.
Peru and Chile.
Buchanan. Okay, Shasta Cascade. All right.
Once we started looking at the numbers, because it was doing it every, whatever it was, 140 years, doing the same pattern.
Right.
Way back. Yeah.
So, I mean, it's really helpful to have these tools with us, like the wiki, or I mean, people donating their time and energy to put the data and information out there, like the USGS does, and EMSC, and some of the solar stuff, and NOAA, and all that. If you can glean from all these things, you can see what our world's doing. It's alive. And because of our lives are so busy, we miss these things. We miss them so fast that we don't understand what our world's doing. And so a lot of us get caught unawares or with our pants down when a crisis happens. We tell these things mainly to say, okay, these things happen, everybody. When you see that happen over there, just be a little bit more prepared, be a little more alerted.
Keep your eyes open.
Yeah. You don't have to be afraid. Just, Well,
I've been expecting like a bigger quake in Southern California somewhere, and also one up by Vancouver Island.
Mm-hmm.
So that's just more like, and there's more confirmed what I was thinking. So it's not good that it's getting.
No, there's no. I think Southern Cal's on a chopping block right now.
The signals are there
to get a 5+.
Yeah.
Closer to 6. It might even be a 6.2, but right in that, not too far. I'm not looking for a 7 or anything.
No,
I think in the greater Los Angeles, no stronger than a 6.7, but no weaker than a 5.1.
But depending on where it is and how big it is, it could be trouble.
Yeah, that's why I say the greater Los Angeles. Yeah. If it's out in the desert, it can go all the way up to a 7.1. I'm thinking Barstow area needs to pop to fill in the gap, because that's the gap that hasn't popped. And it will be right on the Garlock, or just south of the Garlock.
Well, Barstow has gone off.
Yeah, it has in the past. Yeah.
Yeah, by what I don't know on that. I can't remember now what I was looking at, because they've done the fault studies out there.
Right. We did a study and we found out that oh my God, I didn't know it. And I think it went in the 50s thereabouts.
Yeah, I can't remember what the date was or which fault it was. It might have been Calico fault.
Oh, yeah. Calico is right there by Landers and Hector Mine. It's right in between the two.
Yeah. I can't remember which fault it was, but I read it in something. Like one of the ones that came in my email.
You still don't have that open up for all this time, right?
No.
I didn't think so.
No, because I usually read it on my phone when they come out. Because they've been sending me the last few days Southern San Andreas ones.
Well, look, is there anything that about the movement or the way the structure or basically the mechanics of the Blanco fracture zone that really kind of either stood out to you or you'd like to know more about, or is there something that like I said, it just kind of like stood out to you?
Well, it's to me, it's the corresponding quakes that happen either before or after the ones that kind of grab my attention.
What about you, Canuck? When in this little study, what kind of like a surprise maybe for you, or
Well,
kind of
really focusing on that they're all related really to the spreading ridge, the Gorda spreading ridge, because it's moving as a result of that, basically. And when you think back, like what's happened since December of last year when the 7 was down there on the Mendocino part, we'll see that makes sense that that whole Gorda section is all moving down there. So now it's adjusting to it because it's still the Pacific plate all on that, like how it's adjusting to it. Based on
well, there's some people that say the Mendocino is a plate boundary. There are some people that think that it's developing into a plate boundary.
Well, if it is, it goes all the way across to Japan.
Yes. Out into the middle of the Pacific.
Or was it a plate boundary before? Always has been.
Yeah. Very much good. Yeah, very much good.
Identifiable east-west lineament.
Yeah.
Well, if it didn't go all the way down to the core, wouldn't it have to have like a really big quake or?
No, it's not to the core. It's not the core. It's just the crust.
Well, yeah,
like the San Andreas goes through the crust.
Right.
Or is it one of the main lineaments that everything moves on east-west? The spreading ridges, the big ones.
Yeah.
And that's why Virginia is right across.
Yeah, if you're looking on a flat map, looking straight across, the orientation of all of these is closer to the orientation that we're looking now because the Earth is on a 22, 23 degree axis. But when you're looking at this on the USGS, that red line on the bottom next to the Gorda plate, that's actually straight across. And when you do it that way, it goes all the way across the U.S. Interesting stuff. I'd like to know more. I want to know more about the Gorda Ridge and how it functions, and then also the Wanafuka Ridge.
Just do the 2011 example. You had, the big Japan quake. You had the quake in Colorado, and then the quake on the East Coast in Virginia. Well, that's all that same line.
Yeah.
So it's crazy.
Yeah. Yeah. I think on the next rabbit, we'll look at the Gorda Ridge and then the Wanafuka Ridge. Knowing how this Wanafuka plate actually functions in relation to the others, the Mendocino, the Gorda Ridge, the Wanafuka Ridge, and then the Blanco fracture zone. There are other fracture zones up north. Also, there's the axial seamount, which was predicted to erupt in the last summer, and it hadn't yet. Maybe these 6s or 5s that we're having, it may be that's what triggers it.
Or the earthquake could be taking the pressure off of it too.
Because it's spreading it up there too, right on the Wanafuka Ridge. So that would make sense. Because see, it's moved at the bottom, now in the middle. So now it's going to have to do it at the top.
Right.
If you view it as like the whole Pacific plate moving on this eastern side. And it's probably going to affect Vancouver and Haida Gwaii and probably southeast Alaska as well. Right. Because it's all
right. But by knowing how the Gorda plate and the Gorda Ridge works, like we've learned today on the Blanco, we're studying the Blanco because of current events saying that there's been some pretty strong quakes here the last couple of days.
Well, if the Gorda plate institutes the partial Cascadia, you could have that too. So an 8 down there.
Right.
Or 7, which we talked about in the other show. The 7s, right. I think it's happened there already.
Well, I think I don't know how I'll feel tomorrow. What do you got going on tomorrow there, Canuck?
I got to watch the Jays because it's come down to the last day for first place.
Oh yeah. What time is the game?
All the games are 3 Eastern, 4 o'clock my time.
All right, that you're 4 hours.
Yeah, on the last day they make all the games at the same time.
All right, so
Last few years.
and that's 3 or 4 your time, so that'll be done in 7 your time.
Yeah.
And that would be 3 my time. So, let's do another. Let's redo that one that we missed, so we have it in the can.
Yeah.
You know, because it ties into this is really big. Luke, I mean, seriously, the one we just had that failed would have tied into this so much because there was a lot of detail about the Gorda Plate and the Cascades and the Mendocino Ridge. But we never studied the Gorda Ridge and how it functions.
Right.
And that little Gorda Plate there.
Yeah.
But we learned about how the Cascade, how now scientists are saying that the big rip that everybody's crying about or wanting or, secretly desiring for the 9.0, that thing has gone off smaller amounts of 7s and an 8 too.
Yeah, low 8.
Yeah. And that's happened versus the 1700 where it was they believe it was a complete rip, which I don't believe that, but they do. I believe it was a series of quakes, much like what happened in Chile in 1960. But they said it's all one giant quake. Okay.
Well, and there's differentiations depending on who it is. The Canadians say that the big rip in 1700 started at the top and went down, whereas other people say it started at the bottom and went up.
Yeah, I have it in my mind going down from down go up.
Yeah.
But I could be wrong.
So the smaller partial ones are from the bottom up. And there's debates about that between the different geos. But I would say the smaller partial ones would be more likely bottom up than the full rip. And it's based upon all the studies of both the JDF, the Gorda, and the Explorer Plate at the top, which they say now is accreted to North America already, which is where the Nootka Fault is, and where we've had swarms up there all along that top of the JDF ridge, and then it starts going in towards Vancouver Island along the Nootka Fault, it's called.
I got thunderstorms coming in again.
And they think the Nootka is now the plate boundary between the Explorer and the JDF.
That's where it crosses over, right?
Yeah.
Right. And it like totally bypasses the one to Fuca altogether. It's kind of weird.
Like it comes down and then goes into like Vancouver Island, and then it goes around the outside of it down the JDF ridge. So it's weird what it's doing, but it's like it's going around that top of the JDF Explorer Plate for some reason, and that's what they're trying to figure out. But it's not doing that at the Gorda because the Gorda, they say, is still subducting like the rest of the JDF. If you start reading about the Gorda Plate, but we're going to end up talking about all this stuff more because it relates to all look at in order.
Well, and we have until November 6th to get up to Alaska.
Yeah.
By touching these main fault areas that happen all the time. Now, it looks like we're going to be going up the one to Fuca to kind of explain the different sectors and how they go off and how they relate to the Cascades, or they don't, one of the two.
We're going to talk about
and then we get into Vancouver.
Yeah, we're going to talk about like the notable quakes that happened in Oregon and when they were, what fault they're on actually, and what was happening at the same time.
Right.
With all the other ones.
and how it works all the way up into Washington, and then Washington into BC and further up. Because there's a unique thing about Canada and how the earthquakes traverse the top of the globe, and we'll talk about that and where they're happening, and primarily where they happen, and the main faults through that area, because Professor or Nick is only going to talk about Alaska. He's not going to talk about Vancouver. He's not going to talk about BC.
Well, not. We'll see when he gets into it.
Yeah, but he's already said it. He's not focusing there. He's focusing on the geology of Alaska and the structures of Alaska. But I don't know how you can not do Canada when they're so interrelated, because that stuff goes all the way down into Washington, from Alaska. So
from Nick's comments and his chat things that I read when he was doing one of the shows, the people are already putting all the faults all together. Like there, and see, this one comes down to here and comes down to here, and they're doing all the way right from Alaska right down into Washington.
Yeah.
So there's people in the chats and the comments are already doing this. So there's a bunch of Canadians in there. There's a bunch of Americans. There's a whole bunch of. They're all putting it all together because they know their specific faults in their specific region or area, and they're actually doing it. Because I just got a thing today showing it listed one of the comments in there and how they were connecting them all together. So I'm going to have to, because a bunch of the fault names I didn't know that were in between Alaska coming all the way down. They did like everything from the Canadian Rockies to the coast. So they had a bunch of in there that I didn't know.
Well, we talked, I talk about this often, and how I see clearly 3 lines. You want to call it lineaments, you can call it lineaments. But I see 3 plate boundaries, older and older and older. And I see quakes along those 3 plate boundaries and go all the way down. There may even be a 4th. And I can see it where it splits, and it goes down into the park in Wyoming, down into Idaho, down into central and central Washington, and then down along the coast. Where the main quakes in Washington happen on the Olympic Peninsula. I see how it bends through there. I'm very interested in watching and learning about BC, because I don't know, I'm not pissed off with the USGS, but I'm not happy with them because they're so hard to get any information on Oregon 1. And USGS, that's the United States, not Oregon.
Well, I don't know if it's the state doing it or if it's.
Nah, it's the USGS. It's USGS. They got it, but they don't have it easily available to us. I kind of got to wonder why. Also, I don't like the USGS not putting on there the Canadian quakes in, BC.
Yeah, but they really do the same thing with Mexico. Unless it's big enough, they don't bother.
Well, I got you. 4.5 and above. Sometimes it's 4. You can tell when it's not the AI. It's 4 o'clock, 4 or 4.5.
Just an update on the antenna fault stuff. One of the main guys that did that study has now been hired by the government in Yukon to come and do trenches up there. So they're actually starting them right now.
We need that transition. We need to understand how that bend works.
Yeah. So
it comes right out of Alaska. It takes a freaking 90 degree burn. Boom, and you can see it over there.
Yeah, they've hired him up there to go and do all these trenches. So they're like starting it immediately. Like they haven't waited that long after the study came. Now they're going crazy doing trenches up there.
Yeah, and look, if we knew how the faults work from Washington up through BC in the Yukon and over to Alaska, do you think that it would be, pretty crazy to say, yeah, we understand the entire West Coast,
Yeah.
from Alaska down to Mexico? Because I think we're nailing Mexico pretty good, but it's such a dark hole that USGS just doesn't do it for me. I'm not happy. And your Canucks are like part timers. It's not interesting, I guess. I don't know.
Well, I think that it's just the people getting recognized that are working on this stuff. Nobody may even know they're doing it, but because
Right. I think a lot. I think you guys got a volcano that's active right now too. It's not erupting, but I'm seeing out west a lot of earthquakes that lead right into that volcano in BC there. Yeah, just north of Haida Gwaii.
Yeah.
A lot of earthquakes bounce around right there. What's that?
There's all sorts of volcanoes there.
Yeah. Whole little line that goes, all of a sudden it's like, goes straight across. Like, why? It just up this way, but it just goes straight across into that. I don't know.
That mountain range was called one time. Depends on how long ago.
Yeah. We all are wanting things to, work at a certain time frame, aren't we? But those earthquakes are happening in the Canadians site. Let me show you here real quick. Dun, dun, dun.
It's not big. U.S. just care right now.
Just north of Bella Bella, there's small earthquakes. Here, I'm going to share it with you. Share my screen.
Well, there's mountains up there that they know are active too.
So there's volcanoes there, buddy. Come on now. What? Come on.
But I think it's going to make more sense.
Say it again, bud.
I think it's going to keep making more sense the further we go up and see all the faults that are going off.
Right.
I agree with you. And that's what I
really don't
I like about it.
I'm going to avoid it because that's how the plates.
See right here toward Kim's Kut.
Yeah.
Right here. I think right in here there's some volcanoes right out here.
And I want to know more about Alaska too because I haven't studied Alaska as much.
Yeah. South of Prince Rupert, the Hecate State, Queen Charlotte fault that runs right out here. This one's just north of Bella Bella. There's been a swarm, and it's a straight line from the ocean inland.
Yeah.
Gotta wonder why.
And the new stuff on the bottom of the Queen Charlotte Fault at Haida Gwaii or just below, they say that the new stuff on it says it can make megaquakes and big tsunami.
Oh, okay, down here in a south of Haida Gwaii.
Yeah,
that's where the 2 5s hit, maybe 3 5s in 2019. Look at these. These earthquakes happen here, go straight across. That's a plate boundary right there. Bypasses all of this.
They say the Pacific plate is actually starting to subduct there right at the bottom of Haida Gwaii. So that's why they.
Well, that would make today, Sandusky Bay, Ohio, 1883 had a major earthquake on this day in history.
Well, see that in our list. Mendocino, I think, 82, 83, 84.
Hmm.
Well, in 1884 was the New York City quake. Wow.
Check this out, everybody. Just to wet your whistle. Texas LINEAMENT. Okay. Here is our subject right up here in the middle. Follow that through Arizona through California, Nevada, Arizona, right? We run into this one on Trout Valley, New Mexico. We also come out here, Puerto Rico, bang, bang, right? Should see something happen around, what's this little island called out here? I forget. Tristan, okay. Tristan Acuna.
That's the one in the South Atlantic.
Yeah. Right, Ascension Island is what I was referring to. So right out here, and then we should see. We've already seen South Africa go, and over here to Caligula. I call it Caligula. I can't pronounce the damn thing. What's the thing's called?
Kerguelen or Kerguelen?
Kerguelen?
Yeah, Kerguelen or Kerguelen. I say it.
Yeah. That's why I just say what I said. All right. Yeah. This is a Texas lineament. It goes from down here, these islands down here, through Africa, through the Mid-Atlantic, through the DR, Puerto Rico, through
Texas
West Texas.
Gold and diamond mines in South Africa.
Yeah. And it goes to Corpus Christi, through southern New Mexico, through central Arizona, through California, Nevada border, and it comes up right up here, almost on that angle right there. Okay, almost on this angle, and then it continues up into Sandpoint. That's the Texas lineament, and yes, it does traverse the planet. I don't have time to figure it out for you, but that one is a major active area that we watch. Now, mind you, it's not near as powerful and as active as the one that rides out of Tonga through Fiji, through the PNG, Indonesia, up through middle of the stands and up into Iceland. Okay, that one is a more powerful one. Lineament. Another lineament is from Kamchatka through Tokyo, and out through Sumatra, and down along the plate boundary into the Prince Edward Island area. Okay, so that's another lineament. We see lineaments as active areas along a plane that are electromagnetic, because that's the only way we can figure out why it's happening there. So you ask why this, why not that, or how come there and not over there? And when you do that, you have to look for an answer.
Interplate quakes, because to me, the lineaments explain that.
The lineaments explain interplate activity. They also explain as why along a certain plane that is happening. And the only real supposition to that, and it's weak, but it's strong enough for us, is that there are electromagnetic pulses that emanate from the core of the planet, interacting with our atmosphere, interacting with what's going on beyond our atmosphere, such as solar, planetary, or other entities, or even beyond our solar, intergalactic.
Earth's magnetic field. It's all the same.
Yeah, the intergalactic stuff. So, and it takes a lot of activity to do something, but often, because of the core of our planet being the way it is so very, very, very active. I don't even know. I don't know that word. I don't know what it means. Magnanimous. It just popped in my head. I got to look the word up.
Yeah.
Do you know what that word means?
Yeah. I'm getting tired now too.
Mm-hmm.
It's hard to think of the word.
Sighing room, spying room, given meaning. What the frack? Oh boy, where? I guess I'm checking into somewhere. I shouldn't. I don't need the government after my butt. Anyway, I don't see the moon, man. I can't control the seership. I just see what I see and hear what I hear. Timmy's such a slacker. Oh my gosh. Mom's still up. Big hugs, Mom. I think Florida Girl stepped in a hole because she was there, then was gone. Faith, the same thing. They both, oh, I want to go dancing. I think that's what they're doing. Mike was here.
Fall out of my chair here.
Yeah, I understand, bud. I was that way yesterday. I couldn't function. Could not function. Oh, she's on a date again. Okay. She stepped in a hole, so he must be a short date. All right. Let me close it up here and we can chat after the fact. Yeah. Big hugs, y'all. Remember, Joe Slick Live on Twitch. It's twitch.tv/Joe Slick Live. Monday through Friday, 7 to 10. And Wednesdays and Saturdays, Rabbit Hole, 7 to today's 9. 6 to 9. I don't know what day what time we come on. Anyway, we've been on 2 hours and 3 minutes. So we've been on a minute, everybody. Probably about an hour and a half, 2 hours.
Oh,
on a good one.
Shooter reported in Southport, North Carolina, just came out.
Oh, these wackadoodles, man. Wackadoodles. There's another guy who wants to cut his dick off. Why don't he just shoot his dick off rather than shoot other people?
Well, I don't know who they'd be shooting.
You want to use a transmission. You know, those guys have a broken transmission. They want to lose their pecker, and they want to shoot people now.
But I don't know who they'd be shooting at this time.
Well, anybody who disagrees with them. I don't disagree. Hey, you want to cut your pecker off? Go right ahead.
Because it's dark.
I don't care.
So I don't know who they'd be shooting.
You want to be a woman? I'm married. I'm not going to have to worry about it. I don't care what you want to do. And I'm not going to speak evil of you. Just.
So I have to figure out what that's about.
I think it's easier you to shoot your pecker off than somebody else. Hey, it's cheaper that way. Because then they got to try to put it back together. And it just might as well give you a pussy. You don't want one anyway. You don't want a pecker. Am I right? I think I'm right.
One, so they're in the playoffs.
Who's in the playoffs?
The Cleveland Guardians won.
Who's that? You mean the Indians?
Yeah, the Indians. Yeah.
All right, right on.
So Houston,
Flutter Girl, Susan, Faith. Thank you all for being here. It's been a fun time. That other stuff should be, I cut the time off. I can edit that one, but I can't edit the two other ones that are live. Pilar, yeah. Yeah, sister was asking me a question earlier. I mean, when she said Pilar, Phil Kiki was out there too. Why White Cross. Come on. I used to have Petra. I liked Petra back in the 80s.
Yeah.
And Luke wasn't born yet.
Are
He
you
was,
sure?
well, he was born in 1980. He's the last of the Gen X. So I can love my boy and know that, yeah, he's a latchkey kid too, independent and stuff. But it is hey, man, love y'all. Have a good day or good evening. Remember, don't get none on you. And pull my finger, will you?